we said g of x is equal to, I want you now to write this equation down, g of x is equal to 3 sine 2x. Now there's a difference. That is still the same as what we had before. But now we've got a number here in between. In the previous examples, they were behaved, so the number was 1. Very easy. Right? So now things have changed. So before we sketch the graph, again, theory questions that could be asked in your exam. Give the amplitude of the graph. Give the domain of the graph. Give the range of the graph. And state the period of the graph. Okay, we're not yet into graph interpretation. Graph interpretation we'll do in another episode, in our next episode, where we're going to put all these graphs down and you're going to have to determine where is f of x greater than g of x, where is f of x less than g of x. We are now focusing on how to sketch and how to determine equations of these trig functions. Okay, so the amplitude is still 3. We said that number in the front refers to the amplitude is 3. The domain, there we go, x, we normally write it, we don't put it in interval notation. Domain for x, we normally put it as in an inequality form, x less than or equal to 360 but greater than or equal to 0. Right? And we can normally say x is an element of real numbers. Many of you still ask what is the meaning of x is an element of real numbers. You still don't know. It just means that x can be decimals or can be fractions. It doesn't have to be integers, whole numbers, or natural numbers. Okay, range, lowest to highest, lowest to highest. So if the graph is going up to 3, it must go down to -3. So it's from -3 up to +3. And the period of the graph is determined by the formula 360 divided by that number. So 360 divided by, what's the number here? The number has changed. 360 divided by 2 is 180 degrees. And that's the period of the graph. Unlike the previous graph where the period was 360, although the domain says 360, the period of the graph, that means one complete sine cycle, will make its appearance not every 360 degrees, but now every 180 degrees. And how did I get the 180 degrees? I said 360 divided by that number in between. So if that number was 3, 360 divided by 3 would be 120 degrees. Okay, let's now sketch the graph. So now from 0 to 360, we go to our graph. There we go. 0, 90, 180, 270, 360. 90, 180, 270, and 360. We're going to go up to 3. 1, 2, 3. And we're going to go down to -3. 1, 2, 3. There we go. It is a sine graph, guys. It is a sine graph. So a sine graph starts at 0. This number is positive, so it's 0 up. After how many degrees? Now, we also need to find our degree change. So we say 90 degrees divided by that number is equal to the change, degree change. So 90 degrees divided by 2 is equal to how much? 45. So this graph now, this is not a standard dolphin. This is not a standard swimmer. Right? He's now going to be doing tricks. So now instead of, you just keep on saying instead of. So now that means the degree change is 45. So instead of 90, you just keep on saying instead of. Instead of the graph going and turning at 90, it will now go and turn at 45. So 45, 90. So now your intervals won't be broken up into 90s. It will be broken up every 45 degree change. So 45, 90. The next 45 after 90 is 135, 180, 225, 270, 315, 360. So this graph now, his path, instead of him going up to 90, he goes up to 45, comes down, cuts, turns, cuts, turns, cuts, turns, and stops. And there we go, guys. This is supposed to be -3. He can't go below that. Error of parallax. I'm standing here, you standing that way. It looks a little bit skew, but remember, it can't go below my -3, right? And it can't go above 3. So let's just put it there. There we go. And that is your sine graph, right? Your 3 sine 2x function.